In this video, we're going to take a look at a very important type of series, which is called the geometric series. And later, we're going to use it to study many other different series using some techniques that we will learn later on. So, let's get started. A geometric series is a series of the form sum from n equals 0 to infinity of x to the n. So it's 1 plus x squared plus x cubed, and so on. Here x is a real number and very often is called the ratio of the geometric series. And an important thing to note is that it started at 0 and not at 1. It's not a huge deal, but it will play an important role when we want to know the exact value of the sum. Can you recognize these ones? We've seen it before. We saw it when x is equal to 1/2. It was the example that we did just before seeing the formal definition of series, and the case when x equals -1 was the one that we saw that was 1 minus 1, 1 minus 1, 1 minus 1. So we've already seen two geometric series. But well, we would like to know in general for which values of x is this series convergent. Well, so far the only tool that we have at our disposal is a definition, so we need to look at partial sums. So, well, partial sums would be just sum first k terms. Very good. So you see, if x is equal to 1, we're just adding 1 plus 1 plus 1 plus 1 k times. So this will go to infinity. So my series is divergent. Good. In case x equals 1, done. Now we need to take a look at what happens when x is not 1. Okay. So, we're going to look at the form of the kth partial sum. So it's 1 plus x squared plus dot 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 x to the k minus 1. Because remember, we wanted the first k terms, but our sum started at 0. So it should be 1 plus x squared dot, dot, up to xk minus 1. Now, if I multiply both sides by x, we end up with x times sk is equal to x plus x squared plus x cubed plus dot 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 x to the k. And I'm going to subtract these two, and we're going to have that 1 minus x times sk, right, which is the same as sk minus xsk, is equal to 1 minus x to the k. And now I want to divide by 1 minus x. And I can do this because now I'm just worrying about the case when x is not equal to 1. So I will not be divided by 0. Everything is legal, no problem. So we get that sk is equal to 1 minus x to the k divided by 1 over x. So now, solving this problem is equivalent to knowing when the limit of my partial sums exists. So when the limit as k approaches infinity of 1 minus x to the k over 1 minus x exists. So if x is between -1 and 1, we know that x to the k goes to 0 as k goes to infinity. So then my limit of the partial sums is equal to 1 over 1 minus x. If in this case, then we see that, well, the series is convergent, and even more, we managed to find the sum of the series. The sum is just 1 over 1 minus x. If x is bigger than 1, well, the sequence x to the k diverges to infinity, so my sequence of partial sums diverges, so my whole series diverges. And if x is less than -1, we're going to have a subsequence that diverges to infinity, so my whole sum diverges. It's going to be doing crazy things, so it diverges. So in this case, again, we know that my series diverges. And the case x equals -1, we've already seen it. It was the one of 1 minus 1, 1 minus 1, 1 minus 1. And we know that we saw already that we have that the subsequence of the odd terms and the even terms, they converge to different limits. So then the sequence of partial sums is divergent. And because this is very important and we're going to use it a lot, I want to just write here a quick summary. The geometric series, which is the sum from n equals 0 to infinity of x to the n, is equal to 1 over 1 minus x if I know that the absolute value of x is strictly less than 1. And this series diverges when I know that the absolute value is greater than or equal to 1. That is, if x is bigger than 1, diverges. X equal to 1, diverges. X equal to negative 1, diverges. X less than negative 1, diverges. So the only case when the geometric series converges is when x is strictly between negative 1.